Hey guys, this is Dexter from Dexter's Workshop. I promised you a little tutorial on EagleCAD package, how to uh, capture a schematic, design a PCB, and after that generate the Gerber files that are necessary for PCB fabrication. I'm going to use Seed Studio as a fab house, and I'm going to use their Eagle rule files and cam jobs that can be downloaded from their site. Um this tutorial it's pretty long. I guess it's over an hour, but it covers everything from start to end. So you got pretty much cover every aspect of PCB design and schematic capture and Gerber files. So first thing that you'll need to do is to navigate on EagleCAD webpage and go to download section here, download Eagle. You will find the 32 and 62-bit version, so you'll have to download it, the one that will suit your installed system. Already done that, and I'm going to install it. It's a pretty simple process, just click next. So I will recommend you to download it, to install it in a root directory like C, D, or E, according to your drive lettering, or you can also install it on an external drive if you like. Try that, it's working pretty good, so you can have it like portable version. It will take a while to start the installation. Just click next. Yes, I'm going to install it under my E drive. It will take a while depending on your computer speeds, RAM amount. I'm going to click run as a freeware because this is how you're going to use it, except you have a Eagle license to install. Run as a freeware, finish, and here you have it, Eagle 7.3. Install it on my E drive. Next thing I would like to do is to grab my custom-made libraries and copy them inside the Eagle installation directory. I'm not doing this, and I'm using my Dropbox folder to keep my my custom libraries, because I will have access on them from every computer that I'm working on. Either it's my desktop or my laptop or my office computer. So but right now I'm going to use my custom-made collection library, and I'm going to copy it inside the Eagle installation directory. After that, I'm going to start up Eagle software. And you'll have to tell it where to find the custom libraries. So you go options, directories, and as you may see, it's the path to custom library. After you click OK, you'll have to see if they appear under libraries branch. So you'll see custom one. You can use both of library directories, like the one that came with Eagle, or you can use only your custom ones. So if you want to use only one set of libraries, you will have to click use none on the one that you are going to use, and click use all on the one that you are going to use. So we are going to start and capture a schematic. I've choose the AMZ MOSFET booster for this tutorial. It's a pretty basic schematic with some resistors, capacitors, one diode, and a MOSFET transistor. So this will be like click file, new schematic. First thing you will have to do, it's like best practice for this, it's to set your grid. My advice is like always use a grid to work with, and always use the imperial system, because all the devices and all the libraries are created using the imperial system instead of metric one. So you are going to type grid display on, and you're going to choose a size for the grid. I'm going to use 0.0125 inch. It's the grid that is the size that I found that it's suit my needs best. Either I'm working with 3-hole devices, or with SMD, or small devices like 0604 resistors. So you'll see that the grid appeared on your workplace. And what we are going to do next is adding the part. You can either click add on the toolbar, and you'll have all your libraries. You'll have access to all your libraries. As a workflow, I'm using I place one of each type of devices. So I'm going to place one resistor, and I'm going to use the number 3 version of the resistor. I'm going to place it here. After that, I'm looking and see what else I should place. So I have the resistor placed in. I will have to place some electrolytic capacitors, like this one and this one. So I'm going to electropolarize. I'm going to use the 50 volts version, and I'm going to use the one with a bigger gap between the pads. So I'm going to put it here, and after that I'm looking for some polyester film box, if you like, the one from the inputs and the one from the outputs. So I'm going to use the film box caps. It's the first version. So I'm going to place it on my workspace. Then I'm going to use a 9.1 diode, but I'm going to find it here under the diode. I'm going to use this version of diode, or you can use, instead of a Zener footprint, you can use any diode footprint that you like. So a 1 watt Zener, it's equivalent with 1N47XX diode. So I'm going to use this footprint for my Zener diode. Okay, so and I will also have to add a potentiometer. So I'm going to try and find it here. It's under pots, and I'm going to use the wire type. Okay, with pads, not the PCB mounted one. So I'm going to use this one. Okay. What I'm going to do now is practically copy the schematic from the web page, and I'm going to capture it into my design. To have a better workflow, I'm going to use the copy command like this, and I'm going to place the resistors according to the schematic. There is also one device that I will have to add. You can use wild characters to search through the libraries. So I'm going to see if I'm going to find it like this. So yeah, BS 170, and I'm going to place it. I like to keep all tidy and clean, so I'm going to place it near the origin point. Okay. Next thing, I'm going to start and add and you have to be careful when you're going to start and connect the parts, because you wouldn't want to use the wire command or the wire icon. Always use the net. There is a big difference between the net and wire. Wire is just a simple wire, while the net command will enable you to actually connect the parts. If you're going to use the wire command, your parts will not be connected. The wire command is just a graphical one. You can always use Ctrl-Z to undo your actions. Okay, now I'm going to place another resistor here. And I'm going to add the input capacitor right about here. You'll have to bear with me because my weapon of choice was EagleCAD version 6.3, so this newer version, it's completely unknown to me. They changed the icons and some other stuff around here, so it will take me a while to get used to it. You have to pay attention to the diode orientation. So moving a part is just click and drag without any. So you click on the part, you drag it. Rotating a part, it's click and right click until you bring it to your desired position. So we'll have to see. Okay, next. Next we'll have a polarized capacitor there. We'll put it here. Okay. Okay, then we will have to add another part, and it's going to be a ceramic capacitor. It's too wide, so I'm going to use this one. After you're placing a part, you can hit escape, and the add dialog will pop up and enable you to choose another part. If you like to finish the adding process, you can hit escape again, and you will going to return to your workplace. Okay, what do we have here? It's add the output capacitor. Okay, and that should be it. Okay, you can start and delete the parts that are no longer needed by using the delete icon. Click and delete. Okay, you can zoom to fit and see the whole schematic here. Next thing you'll have to do is add all the other symbols to your schematic, like ground connection, input and output ports, and the 9-volt supply. What I'm going to do is click add and search for GND, and I'm going to choose the ground from GM supply library. I'm going to choose the ground, which is use this to hook up ground connections through a schematic instead of running wire. It's much cleaner like this. Adding ground symbols to your schematic will improve the way the schematic can be read, and also will enable to be much cleaner. And also you have to see that it automatically labels the net as GND. So we will add all the necessary. Okay, so we have another one here, and that's it. After this, escape, and now we'll have to use the 9-volt supply, which is listed under supply. 9 volts with a T. That will be a pad that will name your net as 9 volt. Okay, we have to connect this here. Merge next segment and name it plus 9 volts. Click yes. Oh, we just missed one ground connection here. Don't worry about the the names and the values that are overlapping, because we are going to solve that a little bit later with a very useful command, in my humble opinion. That command is smash. Okay, and we are going to add the inputs here and the output here, and we are going to connect them like this. Again, I'm going to say this once more. Please be careful not to choose the wire from the icon. You have to choose the net. The net, it's the command that is going to connect the parts, where it's just graphical and no connection will be made whatsoever. Okay, so this is the schematic that is captured. Now we will have to use either the value command and click on the part, or you can use the icon that is going to run the value command. So I'm using this, and see that, and start adding values. 100k, 62k, C3 it's 10 mic, R4 it's 10 meg, sorry, R4 it's 2k7, also R5 is 2k7, C2 it's 45 or 47. C1 it's 1 nano, C4 it's 100 nano, C5, this one here, it's 100 microfarads. The pot it's 5k, and I would recommend you to use 5k reverse logarithmic. Okay, so that would be it. All the parts got their corresponding values. Next thing that we are going to do is select the whole schematic like this and use smash. So you either use the icon the icon here, or you can click smash, right click and click smash group. That is going to give you the possibility to move around the part name and the value like this. You're going to use the move command and click it like this. Just move them around and keep your schematic clean and tidy. Okay.
after this, you can actually delete the information that is not needed, like port 1. You can delete it because you only have one, and the information is redundant. Also, using the name command, you can change the name of the parts and the nets. Actually, the name command is used to change the name for any element in the schematic or the PCB, and the PCB will or the schematic will be automatically updated with the new information. So I'm going to type it here in, and here I'm going to type out. Okay. So this is your schematic, this is your capture schematic with all the necessary elements to go on the next step. Also, you can rename this point here as +9 volts, and if the value does not change, the displayed value does not change, you can also type the value, because this one here will represent the value, and click yes, I want to change that, and it will be displayed correctly after this. So this is your capture schematic. Next thing you will need to do is transfer it to the PCB design part, and we will start designing the PCB. We are going to save it. It's either by clicking File, Save, or using the shortcut keys like Ctrl+S. We are going to save it local TMP, and we are going to create here a new directory that is going to be Eagle Tutorial, and I'm going to name it AMZ Booster. Okay, so after you capture the schematic, you will have to design the PCB. This you can do this by exporting the schematic into the PCB side of the Eagle package, and you will do this by clicking generate, by clicking the icon here that would state generate switch to board. You will be asked that if you want to create the board file from the schematic, and you'll have to click yes. Okay, there are some again some best practice steps that I would like to share with you. One of it is again, remember about the grid. You'll have to type grid command and again set it to 0.0125 inch. After this, you will have to delete the previous board edges and add another ones that will fit your grid. Doing this is simple. It's select the wire tool like this and choose the layer that you are going to use to draw the PCB edges. The layer that you are going to use, it's layer number 20, that it's named dimension, And practically what you're going to do is just draw some lines. The width that I'm working with, it's 0.012 for the out layer, so you can use it and draw the lines like this. Yeah. When you finished, you hit the escape key, and this is your board outline. You can modify it later by dragging. So you click move, okay, and then drag it to desired dimensions. For now, we are going to let it be like this. Another step that you're going to do, if you are going to use some PCB fab house, it's better to have the design rules and the CAM files that are provided by the PCB fab house, and they generally have them on their page to download them. So you have a set of I'm using Seed Studio for this example, and they provide a DRU file for 2-layer and 4-layer board, also a CAM file that will generate the Gerber files for 2 and 4-layer respectively. So you have to download them. So I'm going to download the DRU file for 2-layer, okay, and I'm going to download also the Gerber CAM file for 2-layer, because we are going to use a 2-layer board. After that, you can go to the path where the files were downloaded, and you can create a directory inside your Eagle installation that it's going to be named, I don't know, rules, and you are going to extract the files. One it's CAM extension, and the other one is the DRU file. Both of files are used to design a PCB. The one that has the DRU extension is the file that holds the rules for the design, and you will have to use that and make sure that your design is compliant with the rules stated by the PCB fab house. The other one, the CAM file, is a collection of macros and operations that are used to generate Gerber files, the files that are needed for the PCB fabrication. We are going to load the DRU file into our PCB design. I'll have to look around here. Okay, so you are going to click the DRC icon from the toolbar, and you are going to click the load button and load our DRU files. And you are going to choose it from the directory where you save it, and click open, click apply, and then select, and that's it. From now on, we are going to place the components inside the PCB outline, and I like to do it in a linear manner, in a linear way. Like I'm going from the input to the output of the board, and I'm going from left to right. It's something I was getting used to it, and usually with a more complex design, I would recommend you to use more of a block approach, of a functional block approach. But this is a simple design, so we are going to from left to right, from input to output. Okay, so first thing you would like to do is use the move command and place the parts. As you might see, we made a little bit of a mistake here. We accidentally connect the input and the output together because the nets are named in the same way. So we are going to correct this by going into the schematic, type the name command, click on the net, and rename it to output or to out. You are going to rename only this segment, not every segment of this shit. Okay? And click OK. After that, you are going to see that input and output connections are disconnected the way that they should be. So okay, the input pad, it's according to schematic, is going to 1 nanofarad here. So we're going to place the capacitor for now in a way that it's convenient for us. After that, we can place our protection diode. If you're bothered by the rat's nest, you can always click on rat nest, and it will rewrite the rat nest as you are placing the parts. We also have the C5 that it's connected here. You can connect them any way you like. Okay. Also, if you're bothered by the fact that ground signal it's shown, you can hide the ground signal until you finish to place all the parts and you connect all the signal lines. After that, you can show the ground signal again. So I'm going to do is type show GND. That's strange. I think it's a little bit of a bug in this version of Eagle. I'm going to use the show command here, and I'm going to click on the ground connection. I'm going to click properties, and I'm going to click airways hidden. I'm going to click apply and OK. That's it. Now You can overlap the values and the names of the parts, because we are going to solve this problem a little bit later on. So now that we have all our parts inside the board, they were placed in a draft manner. It's just told you that it's not going to be a problem. The fact that the names and all the info is overlapped. I'm not going to think too much on parts placement here. And we are going to trim the board roughly again. And right now we are going to start and route the signals. You can before starting to route the signals, you can also select all the parts like this using the group command, and then click on smash, right click and smash group. This will enable you again to take apart the values and the names of the parts. What I like to do is to keep my values on the PCB's silk screen, and discard the names. So I'm going to take the names apart, and instead of names I'm going to put the actual values of the parts. Okay, that will give you a much cleaner design. and we're going to delete the info that is not needed. Again, Z1, we have only one diode there, so there is no need to keep the name. As I was telling you, all the there is also some here. Okay, so this is it. You can always modify the text of the information that will be printed on the board. You can click properties and you can modify the size here. I usually go with the 0.04 with a ratio 0.04 inches with a ratio of 12%, and every time I'm using a vector font, so I can squeeze this inside. Also, having only one transistor on the board will allow me to delete the info because I already know what kind of transistor I'm having here. So and I'm rethinking a little bit the layout. It's better not to take the advantages of having a double-sided PCB and do all you can to have a good placement of the parts. Also, we are going to modify this to 0.4 and vector apply. Okay. It's a little bit of, I don't know, it's like solving a puzzle and trying to have the best placement for the parts. I do think for this this tutorial this layout is more than enough. Okay, there are some pitfalls before you are going to start and route your PCB. There are some pitfalls that should be avoided. First of all, when you are going to run the route command, the default layer is top, so I would go and change this to bottom first of all. Second of all, I've seen some designs that we're using straight lines and straight angles. It's not recommended to do that. I would recommend you to use 45 degrees. Every time you'll have to change the direction. So every time you'll have to change the direction, I would recommend you to use a 45-degree angle. That will be a wire bend style one, and this will ensure that your angles will stay at 45 degrees. Also, you don't want the corners to be rounded, and I'm choosing straight miter wire. Also, I'm changing the width of the trace. 0.12, it's a little bit too thin for especially for this kind of project, and generally speaking for any kind of project. If you are using the through-hole devices and full-size resistors and capacitor, it's better to have a thicker trace. So I'm going to 0.032. You can go with 0.04. I'm going to start with this, and I'm going to change it on the way if changing the thickness it's needed, but I don't think it will be the case. Just arranging a little bit here and here, and that should be it. So we are going to start and route our signals. First, I like to start and route the obvious, especially for this simple project, the obvious ones, the signals that are in straight lines, that are closer to each other, and after that I will solve the other issues on the run. Also, I like to route my signal traces on the bottom and have my supply voltages and supply signals on the top. Again, you can do it other way. Anyway, it's good. You are not designing high frequency PCBs or radio frequencies that requires a lot of work. Then it has a lot of I don't know, technology behind. So for this PCB, just start and route. So we are going to issue the route command with previously values, so we are going to route it. I was telling you about the 45 angle, so every time you will change direction, Eagle will ensure that there is a 45-degree angle there. Okay, as you might see, all the signals are connected right now. The supply voltage is going to be on the top layer, so I'm changing layers here. See, I'm going with the top layer. The same trace, the width. Okay, so this is our finished layout. Some of you would like to have a ground connection near the input pad, so we are going to add this in the schematic. by having a ground connection. Choose a grid signal, a ground signal that has attached a pad. Click OK. Have it here. And connect it to our circuit ground. Again, using net, not wire. Just to be sure, we are going to save it, hitting Ctrl and S, and our pad appeared. We can also rename it by issuing the name command, clicking on it, and have it ground. And we are going to use the smash command, smash it, and move the text here. So right now we're having the input, the output, our 9-volt supply, and our ground connection. What I'm going to do next is show the ground connection, that the ground signal that was previously hidden, and I'm going to do that by issuing the rat's nest gnd. So all our ground signals are appearing inside the PCB outline. And what I'm going to do is route the ground signals right now. You can use the top layer or the bottom layer. So we are going to route the ground connections manually right now. Okay, and I'm going to show you how to use for command and for ground planes. It's fairly easy. It's fairly easy to do that. Let's see. We can increase a little bit the dimensions just to have some clearance. Okay, and we are going to move, and we are going to route. You can either route it this way, like this, and it's good, or you can route it this way. So here we have, if you are going to route it here, your ground connection, you can have a more compact design because you can modify the dimensions of the PCB. So this is it. Just to ensure that everything is connected and everything, no traces are left unconnected, you can hide the layers, and you are going to do this by clicking on layer settings. You can click none, apply, so none of the layers are visible right now, and you can click to show the unrouted layers, and if something will appear on the screen, then you will know that you have one or more unrouted signals in your PCB, and you'll have to solve that. You can click all, and all layers will appear. Also, you can see that some layers are new here. That would be solder mask, and the drill markers and stuff like that. I'm always working with all layers visible, so I'm clicking all, apply, OK, especially when I'm dealing with a simpler design like this. After you finished with all the routing and your board it's ready to be fabricated, you will have to check with the previously loaded DRU rules, and you are going to do that by clicking the DRC. We have our Seed Studio 2-layer DRU file that was previously loaded, and click check. You will have some errors here. Some of the errors you can ignore, some of the errors you cannot. Those errors are telling me that the stop mask, it's overlapping the pad. That it's okay, because in the process of making the PCB, the manufacturer will not have the stop mask and the outline of the part printed over the pads or over the stop mask. So you can ignore that. We have 4 of such errors, but they're not particularly, they're not errors, they're just warnings, because you can ignore that. Also, if you would have some unrouted signals, you will be prompted here. And also, just for the purpose of demonstration, if you are too close or you overlap a pad, you will also get some errors. Drill distance. You will get a drill distance error, and this is one of the errors you will have to deal with, because that's a critical error and you'll have to solve it. By ignoring it, the PCB would be not valid with the DRU rules, and probably you will get it back from the manufacturer, and they will tell you to solve the error. So usually the errors that you will have to solve are unrouted nets and drill distances, or clearance between let's see, if I'm going to unroute a signal and I'm going to route it here, you'll also get an error. Okay, I'm clicking check. Clearance again. Clearance, errors, and you'll have to solve that, and overlap your errors. You'll also have to solve that. I'm going to hit Ctrl+Z. Undo. Okay, so we are going to check it again and see that only our stop mask errors are here. And I'm going to approve that. Approve. You will see that the errors are on layer 29. Okay, and if you want to see what is layer 29, you can look on the layers and look for 29. It's the top stop. Okay, it's the stop mask that it's overlapped by the place, by the layer 22, and told you it's okay. It's not a critical problem at all, and the manufacturer will solve it without any problems. One more thing, adding text. It's very easy. You can click on the text icon here and type in the text you'd like. It's Eagle PCB. Click OK. But you'll have to change the layer. If you would like to appear on the silk screen, then you will have to choose from one of the two layers. You can either go from top place or top names. I would go with the top names, or you can put it on the value layer. It's irrelevant because it's practically just a piece of text. So I'm going to use it and put it on the top place, because this way I ensure that it will appear on the silk screen of the PC. I'm going to click it, escape again, click here, properties, and I'm going to use a 0.05 with a ratio of 12% and a vector font. So you can move it around, place it where you like, and I'm going to place it here. So that's about it regarding the PCB design. Now that your design is ready to be fabricated, you will have to export the design to industry standard that is called Gerber files. And you are doing that by running the previously downloaded CAM file. So if you are going to the file menu, CAM processor, you will have file, open, job, and you are going to choose the CAM file that was previously downloaded from CAD Studio website. So here you will have all the necessary information to generate the Gerber files. There is no need to use to generate your own CAM job if you are going to use CAD Studio or other manufacturing companies, because they usually provide you with such files. Here in those tabs you will see that they're named according to the job that they're going to perform. So this is the paste top, solder, mask bottom, mask top, silk bottom, silk top, and each one of them they are going to be exported in a RS274X standard, except for the drill files, drill holes, that are going to be exported in Excellent standard. And each file will have a certain extension according to manufacturer standard. It's GBP for solder paste bottom, it's GTP for solder paste top, and so on. For I don't know, top layer, it's GTL. For bottom layer, it's GBL, it's Gerber bottom layer, and GTL, it's Gerber top layer. You don't have to change anything here, and you are going to press process job, and that was it. Your files will reside in the directory where you saved the project, that, if I remember well, will be in TMP Eagle Tutorial. So here you will end up with a bunch of files, but according to the CAD Studio standard, you will have to include some of the files, not all of them. So we are going to take the names and the extensions and see. So we need GTL file, that is here. You will need GL2, GL3 are not used, they are used for 4-layer boards. The next one will be GBL, so it's GBL. GTS, we're going to take GTS file, we're going to take GBS, okay, the GTO and the GBO, GTO and GBO, and the TXT files, that is this, and the GML, that is the mechanical layout. We are going to create a new directory and name it Gerber, and we are going to cut our necessary files and then paste them into this directory. Those are the necessary files for PCB fabrication. If you would like to check again the exported files, I would recommend you to use a software that it's called Gerb-V. It's a Gerber viewer and it's free. I will post the link in the video description, and you can use this and see how your layers will were exported, and check if everything is in place. I'm going to click the plus sign and I'm going to choose my Gerber files from the directory like this. So you click on one, hold shift, click the last one file and click open. You see that all the necessary information it's posted here. You can check out for messages here on the messages tab. The messages will appear here if there are any errors with the Gerber files. After that, you can close it. They usually asks for a zip archive, so I'm going to Gerber zip. I'm going to name it booster, and that's it. You can upload it on the site and place an order for them.
So that was the end of the Eagle tutorial. I do hope you enjoy it and you will find it useful. If you find it useful, you can subscribe on my YouTube channel, and if you have some questions or you think that some things are not covered in this, please ask questions and I will gladly answer them. Thank you for watching this, and I hope you will enjoy this video. The next one, as I said last week, will be about debugging, about guitar pedal debugging and what to do when it doesn't work. Bye bye guys, and take care.